Hey y'all. The first topic that I'm going to discuss with you is over expressions. So let's start by defining what an expression is. An expression is simply a mathematical phrase that contains numbers, variables, and operations. The important part here, though, is that an expression has no equal sign. And that's the really important thing to note with an expression is it does not have an equal sign. All right, so on the next few problems, our directions read, write an algebraic expression for each verbal expression given below. In other words, they're giving us the words and we need to write numbers and symbols to show what those words mean algebraically. Number one, the difference between the product of a number and 6 and 8. This problem has a lot going on with it, so let's break it down. Difference tells us to subtract, and we want to subtract this product and 8. So we're subtracting some kind of product and 8. Product means to multiply, and 8 is simply the number 8. These are making up part of our expression, the left and right side of our expression. On the left side, we have that product, the multiplication. On the right side, we have the 8. Well, this still looks funny. We need to figure out what we are multiplying. So if we go back to the verbal expression, it says the product of a number and 6. A number is really vague. That tells us we do not know what the number is. So we're going to name it a variable. It doesn't matter what you use. I'm going to choose to use x this time. So we have the product of a number, x, and 6. So we're multiplying x and 6. Currently, this isn't how you would really see it, x times 6 minus 8. So let's rewrite this in the appropriate mathematical way. So instead, we're going to have 6x minus 8. All right, number 2. The sum of x and y increased by the quotient of x and y. Again, let's break it down. We have the sum of x and y. This is grouped together by this comma. So let's deal with that. The sum tells us we're adding x and y. So we have x and y being added together as a group. To group it, we need to put it in parentheses. This sum is then increased by something else. Increased by tells us to add. It's increased by this quotient of x and y. Quotient is a vocabulary word y'all tend to forget. Quotient simply means divide. So we have the quotient division of x and y. So I have x being divided by y. And that's it. Number 3, the quantity of c squared decreased by b less than 10. Again, let's start by breaking it down. Quantity means parentheses. And I like to remember that by the curlies on each side with your q and your y. Together, those make parentheses. So we have the quantity of c squared. So this is our quantity, c squared. And c squared is being decreased by something else, which tells us to subtract. It's being decreased by a whole nother other unit going on here. B less than 10. Less than means to subtract, so we have yet another subtraction. And the special thing with less than is it's a switch word. So whatever's in the back goes in the front. And the back of less than is 10, so that goes in the front, and the front B goes to the back. Let's read through this sentence again and make sure we have everything. The quantity of c squared, okay, c squared should be in parentheses because of quantity, is decreased by b less than 10. Now, it is telling us that this quantity is decreased by this other unit over here. This is a whole little unit here. the whole little family. So to keep it together, we should put it in parentheses. And that gives us our algebraic expression. Number 4, twice the sum of 4 times A and B. Twice tells us to multiply by 2. We're multiplying this sum, addition, this sum of 4 times A and B. Now if we read back through that, that doesn't quite make sense. The sum of 4 times A and B, well, sum means to add. So that really tells us this and part here is where that plus is going. So if I were to write my plus here, on the left side of my plus, I have 4 times A. 4 times A. On the other side, I have B. And 2 is being multiplied by all of this. So to show that, I must use parentheses. Now, I know these problems are very tricky, and I went through them very quickly. But all you have to do is slow down, break down what's happening, and then the most important step is to go back and read your sentence and make sure what you wrote makes sense with that. Number 5 says, choose the correct verbal expression for the algebraic expression. Well, let's see what's happening and what they give us. We have x up here, and x is being cubed. We have division, which is called a quotient. And we have the number 5. So let's look through what we have here. C and D use the words product, so that can't be it. And then A says that x is squared, but it's cubed. If it has a 3, 3 is cubed. Number 6 says, write an algebraic expression for each verbal expression. The length of a rectangle is 6 units greater than its width. Write an expression for the length. So let's draw a picture. We have a rectangle, and we have its length, and we have its width. They tell us the length is, which means equals, 6 units greater than, which means plus the width. So we have our length is 6 units greater than the width. And that greater than switches it, so we have W plus 6. Then the problem asks for an expression for the length. Well, we just found that. It is W plus 6. Number 7. Chris wants to buy his girlfriend a charm bracelet for her birthday. The cost of the bracelet is $85 plus $15.25 for each charm. Write an expression to find the cost of the bracelet if Chris purchases C charms. So we know C goes with the charms, and we also saw that $15.25 goes with the charms. That tells us that they're going to be multiplied. But if we read back through the whole problem, we see that that is not the only cost. There's also a cost of the bracelet. Now, since he's buying only one bracelet, we only need to add this one time. So we have 85 plus 15.25C. Number 8, Shani earns $545.25 less than 2.5 times her brother's monthly salary. Write an expression for Shani's salary in terms of her brother's monthly salary. So what they're asking us for is they want us to write something about Shani's salary, but we're going to use the brother's salary to explain it. So we need to know about Shani. Well, it tells us Shani earns $545.25 less than tells us to subtract, and it's also special because it means to switch. Whatever's in the front goes to the back. What's in the back goes to the front. 2.5 times her brother's monthly salary. We don't know what the brother's monthly salary is, so we need to call it a variable. I'm going to name it B. So I know I'm subtracting, and in front of my less than I have 545.25. So that goes in the back of my subtraction symbol. In the back of less than, I have 2.5 times her brother's salary, or B. So that's going to go in the front. 2.5B. And that gives me my expression. Writing expressions is not the only thing we do. We also can simplify these expressions. But before we get into it, let's refresh ourselves on some vocabulary. A term is a piece of an expression or equation. For example, we have 5x squared y minus 3y plus 2x minus 10. Every single one of these pieces is called a term. Notice each term is separated by an addition or subtraction symbol. Like terms are terms that have the exact same variables and exponents. Like terms are the only things that can be combined. If they are not alike, you cannot combine them. Let's practice this below. The directions say, if possible, simplify each expression by combining like terms. Number 9, 4x plus x minus 3. We have 4x, which has an x on it. That means it can go with anything else with an x on it. So I've got another x here. 4x plus 1x gives me 5x, and I'm left over with that minus 3. Number 10, I have 13x squared. This can go with anything else that has an x squared, not just an x, but it has to be an x squared. Like terms have to have the exact same variables and exponents. So 13x squared can combine with this negative 10x squared. When I put 13 plus negative 10 in my calculator, I get 3x squared. And then I still have this plus 4 left over, so I must write it. Now on number 11, I have 12x squared, and I have 6x to the 4th. These cannot be combined because of the different exponents. If they have different exponents, they cannot be put together. So this is already simplified. Okay, let's try this below. Number 12 says to simplify. Well, in order to simplify this, I have to deal with my parentheses first, which means I need to distribute. Every time you distribute, you use multiplication. So I have 4 times a plus 4 times 7. 4 times a is 4a, 4 times 7 is 28. Then it says evaluate if a equals 5. This means everywhere I see an a, I replace it with a 5. So I have 4 times 5 plus 28. These are all numbers here. Whenever you have all numbers, you can throw that straight in your calculator, which will give you 48. Number 13 looks scary because of the fraction, but it's the same idea. We're still going to distribute. So I have 1/4 multiplied by 20ac minus 1/4 times 28. Well, when I put 1/4 times 20 in my calculator, or when I do it in my head, that gives me 5ac minus 1/4 times 28, which is 7. 5 has variables AC, 7 has none, so that's as simplified as it gets, and your answer is 5ac minus 7. Number 14, again, it has parentheses, so we have to first distribute. I have 8 times y plus 8 times 2x plus 7y. 8 times y gives me 8y plus 8 times 2 is 16x plus 7y. I have some like terms. I have 8y and 7y, so I'm going to go ahead and combine those to get 15y plus 16x. Now I need to evaluate it if x equals 1/4 and if y equals negative 1/3. So I have 15 instead of my y. I plug in that negative 1/3 plus 16, and instead of x, I plug in that 1/4. Again, all numbers here. Once you have all numbers, you can put that in your regular calculator window, which would give you -1. Okay, number 15. Again, you've got parentheses, so you have to deal with them first. Now this time you have to be careful. You have to make sure when you distribute, you take the sign with the number that you're distributing. And here in front of the x plus y parentheses, there's no number. So that means we have an invisible 1, and we're going to distribute a -1. We're not doing anything with 18 in the front though, so I'll just rewrite it. And then I distribute my -1/2 to everything in the parentheses. And then I distribute my -1 to everything in its parentheses. Now I have two minuses here because you have a negative and a negative. Now if you're really great with your signs, you know this turns into a positive automatically. So we have 18 plus 1x, that's not true, minus 1x plus 2xy minus 1x plus -1y. From here, we need to double check that we can combine like terms. 18 has no variable, so I can't put it with anything, and I'll just rewrite it. -1x has an x on it, so it goes with anything that has an x only. And here I have an x only, so those go together and give me a -2x. Then I have this positive 2xy. Well, it only goes with things that have an x and a y, and nothing else does, so I just rewrite it. And then finally, we have this -1y, which is left all alone on the end. And that is our expression. Okay, almost there. The length of a rectangle is x plus 2 meters long, and the width is 8x minus 4 meters long. Write an expression to represent the perimeter of a rectangle in simplest form. Let's draw a picture. We have a rectangle. It tells us the length is x plus 2. The width is 8x minus 4. And it wants us to write an expression for the perimeter. Perimeter just means to add all of your sides, or if you're very savvy, you remember your formula from last year. But I'm just going to add all of our sides. Now, to simplify it, I need to combine my like terms. So here I have an x. That can go with anything else that has an x on it, like 8x, x, and 8x. So I have x plus 8x plus x plus 8x, which gives me 18x. And now I have a 2, which has no variable. So that can go with anything else that has no variable, like this -4, this +2, and this -4. So I have 2 plus -4 plus 2 plus -4, which gives me -4. Now it says evaluate the perimeter if x equals 3. So everywhere I see an x, I replace it with a 3. So I have 18 times 3 minus 4. Again, you have all numbers here, so you can put it in your calculator, and you get 50. So our perimeter is 50 meters. And then finally, last but not least, find the perimeter of this square in terms of r. Again, perimeter just means to add all the sides. So that tells me I need to find all of the lengths of these sides here, but they're not labeled. But I notice I have circles inside the square. And I know the radius of the circle. I also know that the radius in a circle is the same everywhere. So this radius is also r. This radius is also r. And this radius is also r. And I see these circles are all the same size. So I can label that here as well. And I can also label that here. Well, now let's use that to find the length of our side. This length is 1, 2, 3, 4 r's long. This side is 1, 2, 3, 4 r's long. And I know it's going to be the same on every side because it's a square. Now to find the perimeter, I need to add these all up. Since they all have an r, I can combine my like terms. And I have 16r. That's it. I hope this was successful. It's now time for you to complete your post assessment.